As new energy applications continue to scale, battery thermal management is becoming a key factor in performance, safety, and lifespan. At the core of battery thermal management systems, battery cold plates play a critical role across electric vehicles, energy storage systems, and high-power industrial equipment. Their primary function is simple, but essential, keeping batteries operating within the optimal 20 to 35 degrees Celsius range. This helps prevent thermal runaway, extend battery life, and ensure stable, efficient system performance. To meet diverse application demands, manufacturers rely on advanced materials and precision manufacturing. Aluminum alloys remain the mainstream choice thanks to their excellent balance of thermal conductivity, lightweight design, corrosion resistance, and cost efficiency. For high-performance requirements, copper-based solutions are also applied. Using processes such as stamping, extrusion, brazing, and CNC machining, cold plates can be designed with serpentine or parallel flow channels and integrated structures compatible with CTP and CTC battery architectures. Every unit undergoes strict pressure and leak testing to ensure long-term reliability under demanding conditions. Customization is where leading manufacturers truly stand out. From passenger EVs to commercial vehicles and large-scale grid ESS, cold plates are tailored in size, thickness, flow design, and cooling media compatibility. Large format solutions, up to 1.3 by 2.3 meters, support complex industrial and stationary energy storage systems. Looking ahead, innovation continues to reshape the industry. Smart sensors, AI-ready controls, advanced alloys, and 3D printed microchannels are enabling lighter designs, higher heat dissipation, and greater energy efficiency. As electrification accelerates, reliable battery cooling is no longer optional, it is fundamental.